Alright, so precision is the word that we will talk about first, which has to do with significant figures. Precision is going to be found in your general chemistry books. Generally, it goes along with the term accuracy. So precision, if we do a common scenario that we'll see with a target, would be is if anywhere your dots, which are data points or some sort of thing, are close together. They don't have to be near the bullseye, but as long as they're close together, that's a good thing. Accuracy is how close you would be to the bullseye. Precision is how close together your data points actually are. So those two things, precision and accuracy, are different, but precision is what we're talking about with significant figures. So how well your data represents what experiments you're carrying out or whatever you're trying to represent. So let's move on with the talk. Significant figures. So let's go over some examples, and I apologize for being left-handed, but I will move my hand out of the way as soon as I get done writing each thing so you can see it. So how many sig figs are in each number that we're going to show here? So I'll give you three examples. We'll go the first one. We'll look at the number 112. Second one will be number 111. And third number will be just 11. Fourth number will be 24.62. Okay, so with each one, what you want to do is any non-zero number, so this is a general rule, any non-zero number is going to be significant. So right here, we'll see 3 sig figs, and those sig figs will be numbers 1, 1, and 2. And then for the next one, same type of thing, you'll see 3 of them, and those will be the numbers 1, 1, 1. So you guys get the idea. This one, 11, has 2, just the 1 and 1. And then in part D, the number still unaffected by the decimal point. They're all non-zeros. So the numbers 2, 4, 6, and 2 are all significant, so it has 4 significant figures. So let's move on to a maybe a little bit more confusing point, which would be the role of the number 0. There are some special rules with the number 0 that are confusing sometimes, so let's go over those real quick. So I'll introduce each rule and we'll kind of go over an example for each one. So if a 0 is sandwiched between 2 non-zero numbers, it is always significant. So an example of that would be 101. So right here, we would have 3 significant figures, which would be 1, 0, and the 1. I guess another example of what this wouldn't be is if you, say, had 110. You would only see 2 significant figures because this 0 right here is only out on its own. It's not sandwiched between anything. So the only 2 significant figures are 1 and 1. The next rule that we're going to go over is decimal points. So whenever you have a 0, which would be after the decimal point, after numbers, is a placeholder 0, which means it's significant. So number which we could look at would be, let's go with 112.260. Okay, we see that there's 1, 2, 3, 4, 5, and 6 significant figures because, again, 0 is after the last number after the decimal point, which means it's significant. So we have 6, and we'll just go through this for completeness. 1, 1, 2, 2, 6, and 0. Okay, so another rule that we're going to go over, I'm going to change the sheets out for you guys. Another rule that we'll go over is leading zeros which lead in. What I mean by that is if you have 0.000055, you would think normally that these 4 zeros would be significant, but actually it's only the 5 and the 5 that are significant. So any zeros that lead in after the decimal point are not significant. They have to be between two numbers or after numbers to be significant. So again, if that's confusing, like I said, just leading in zeros are always not significant. So these guys, no matter how many of you had, if we have 440 or 400, and there's a 55 after them, there's only 2 significant figures. So let's go on to the next topic. We'll start getting into some operations here. We'll go with addition, and I'll abbreviate that ADDN, and subtraction. So for addition and subtraction, there's one simple rule. We'll do 3 examples here and use pretty much the same numbers for them. So we'll start out with 76.282 plus 50.17. Okay, so as we can see, the top number has 1, 2, 3, 4, 5 sig figs. The bottom number has 1, 2, 3, 4 sig figs, and this 0 is significant again because it is sandwiched in between 2 non-zero numbers. So if we add this up, just do some simple arithmetic here, carry this guy, go through, you have a 6, 126.452. Okay, so if you want to use sig figs, what's the proper number of sig figs for this number, or this answer? The answer is 126.45. Now, reason for that is we're going to stick with however many numbers are over on the right side of the decimal point. We're going to use the fewest amount. So the bottom one, 50.17, has 2 numbers past the decimal place. So that means that you're going to keep only 2 numbers after the decimal point, even though you have 3 in your original answer. So same type of rule holds with attraction or subtraction. What we'll look at are the same numbers again. So simple arithmetic, you have 2, 1, 1, 6, and 2. So 26.112. Again, what happens is due to the 50.17, there's 2 numbers after the decimal place, or to the right of the decimal place, which means that we will do 26.11 as our final answer. So if we are going to look at just a third example, this one will be a little bit different, but let's say we had 101.84, and we'll add to that 25. What you'll see is you'll get 126.84, and if we round that to our significant figures, we don't have anything past the decimal place, so what that means is we will just have 127. So that does it for addition and subtraction. Those are pretty easy rules to go by. We'll go through some multiplication and division next, and that'll wrap it up. So for multiplication and division, last topic we'll cover for this video. So with multiplication and division, what you'll see is we'll go through 3 examples here. 3 always seems to be a good number to do these things in. So let's go with 22 times 20. First you have 0 times 2, 0, 0 times 2, 0. So 0 for the first part, carry that 0. We have 4 and 4. So we initially expect an answer of 440. Okay, so with this, you'll see that we have 2 significant figures here we have one significant figure here. So that means the rule is that you keep the significant figures as low as possible. So we only have one significant figure that we want for this answer. Right now we have 2. So that means our answer will end up being 400. Now, sometimes with multiplication and division, there is some inaccuracy that comes from doing these sig figs too early in calculations, because 40 is a big difference. That's actually like a 10% difference almost for 440 to 400. So that's why some inaccuracies come in. So if you're going to do calculations in a lab, wherever, and you use sig figs, make sure that you keep all your numbers in those long decimals the whole way through your calculation, and then you utilize sig figs at the end of it. That is because you want to keep your data as accurate as possible. So let's move to the next example. We'll do some division. So we'll do 6.8 and we'll divide that by 3. Okay, so we have 1 sig fig, 2 sig figs for that number, and we have 1 sig fig here. What our answer ends up being is some long decimal, which I will write out some of it. Basically 6 repeats for a long time, so we'll round it off to 7. So right now this has a ton of sig figs. 1, 2, 3, 4, 5, 6, 7, 8. Obviously we don't want 8 sig figs in our answer, since our 2 initial numbers only had 2 and 1 sig figs. So what we end up doing is following that rule. Same for multiplication as it is division. What you want to see is the lowest number of sig figs from your original numbers that you used. So 1, again, is our lowest amount of sig figs. So this whole long answer ends up being just 2. Let's look at one last example. So if we do 76.8462 and we multiply that by 1.10, our answer will end up being 84.53082. Obviously we have a lot of sig figs in that answer. Up top we have 1, 2, 3, 4, 5, 6 sig figs for that number, 1, 2, 3 for that one. So what you'll end up seeing is we want our answer to be 84.5. So again, this is because 110 right here is actually 1.10. It only has 3 sig figs. So just keep that in mind when you multiply and divide, that you're going to keep the lowest number of sig figs as you can. And again, when you're doing long calculations or multi-step calculations, keep your data as detailed as possible the whole way through. And then if you present it in a chart or your final answer, that's when you use your sig figs, so that again your data is accurate the whole way through. Again, going back to the beginning of the video, bringing it full circle, accuracy is as close to the bullseye as possible. And like we said with sig figs, we like precision, so that is helping us just be in close together. So dot dot dot, not dot dot dot. So we like this guy right here. So again, this is just some rules for sig figs. If you have any questions or comments, let me know. I can post video responses to them. More than happy to do that. And my channel name is Origin Chemist, so feel free to subscribe. More videos are coming on chemistry, and I will be doing calculus through DiffyQ. So again, if you have anything that you would like to see, let me know, and I'll try and get that up here for you. So have a good night, guys.